but it's not really difficult. So we're going to continue with, this is section 2-3 continued, and this is called the rational zeros test. And Descartes rule of signs. Descartes was some famous math guy, okay? And so the rule of signs says, if you see a stop sign, you better stop, and that's the rule, okay? Otherwise, you're going to get a ticket. No, that's not really what it says. That's not Descartes' rules of signs anyway. We already talked about this, so I'm not going to talk about that. We already did ones like this. See these little dots? That means that, what does that mean? That means that there was a question built in that you were supposed to answer, but we're not doing that, okay? This is it, rational zero test. So this is, so not every, first of all, a rational number is one that can be expressed as a fraction, okay? And it could be negative or positive, okay? You know, I would not write this whole horrible thing down, okay? I would just know that the you have P's and Q's. And don't ask me why, but they call this letter Q, well, it's not really, the factors of the leading coefficient, those are your Q's, all the factors. Have you done this before?
Yes.
Maybe yes, maybe no. The factors of your constant term, those are your P's. This is where you get your P's. This is where you get your Q's. If you take all the possible combinations of your P's divided by your Q's, that's all the possible rational roots that you could have. That doesn't mean that every one of those is a root or a zero of the polynomial. All it means is that it is a possibility, okay? But those are the only possibilities for rational roots. Keep in mind that you could also have irrational roots, and those ones are just crazy. No, irrational means they have like square roots and stuff in them, or they have things that can't be expressed as a decimal, okay, or a fraction, okay? So this is just for finding rational roots, but what it is, it's a way to figure out, before we use graphing calculators, mostly now, you'll probably be asked to do this once on a test, okay, once or twice, just because it's a thing that I remember learning in high school, and it's important to know that it exists, but now we have calculators to find the roots and stuff like that. I'm not sure what they do at the college level, but if they make you find these all by hand. But if you're finding all the zeros by hand, you have a bunch of little tools to do that, okay? So for instance, in this one, okay? So your P's, okay? The P's are the P's. So your P's are all the factors of negative 15, okay? Or of just 15, okay? So what are all the factors of 15? 5 and 3. What else? So usually we do it, start with the smallest one. What's the first factor of 15, the smallest one? 1 or negative 1. So usually I put a plus or minus 1. What's next? Plus or minus 3. Plus or minus 5. And plus or minus 15. Those are your P's, okay? Your Q's are, what's all the factors of 2? Plus or minus 1 and plus or minus 2. Now all you have to do is find all the possible combinations of the P's divided by the Q's, okay? And you could just put a plus or a minus in front of each one, because if one is a positive and one is a negative, then it's negative, right? If they're both negative, then it's a positive. So the first one would be, who can tell me one combination of the P's over the Q's? So the P's over the Q's are Well, smaller than 1. I like to start with the smallest one first. 1 over, not 1/15, it's not q's over p's, it's p's over q. So what's this? 1/2. Everyone see where that came from? 1 over 2, okay? Then the next smallest one would be 1, I think, right? There's no other thing that's smaller than 1. So then plus or minus 1. And you'd have plus or minus, so plus or minus this over this. We already got plus or minus this over this. 3 over 1, not yet. Let's do 3 over 2, right? We do 3 over 2? Plus or minus 3 over 2. Plus or minus 3, I think, comes next, right?
5.
Yeah, let's just go plus or minus 3. Let's just work through these, okay? Plus or minus 3, right? Plus or minus 5 over 2, right? Plus or minus 5 over 2, plus or minus 5, and plus or minus 15 over 2. I'm messing up with my, sorry. Plus or minus 15 over 2, and then plus or minus 15, okay? 15, do you see the 15? Plus or minus 15. Those are all the possible rational roots, okay? So I know that this one has at least one root because it's a cubic, right? It has one real root. I don't know if it's rational or not, but I could try by plugging in all these numbers to see which one works, okay? I'm not going to make you do that on this, but it can be a lot of work, right? Because you'd have to try 1, 2, what happened here? Plus or minus what? Is that just an extra plus or minus?
I think so.
I think so, okay? So, so you'd have to try 1/2, negative 1/2, 1, and you'd have to do synthetic division and see which one of those gave you 0 as a remainder, and that would be your rational root. Get it? Okay? I'm not going to give you one where you have like 37, and usually I'll tell you 2 is one of the roots. Find the remaining 2 roots, in which case you could just factor what's left over or something. I'll do one. You'll see that. So here we're just finding the possible rational roots. Okay, so here's a nice, easy one. Okay, again, this doesn't need to be a multiple choice question. In the last year, I had people answering as we went along, but it was too much work, so we're not going to do that. Whoa, far out, man. All right. So anyway, find the rational zeros of this. So possible. So what are the p's? P's? The p's. P's, man. Plus or minus 1, right? Right. That's the factors of this. And what are the possible q's? Plus, also plus or minus. Easy, right? So the only possible p's over q's, right, are just plus or minus 1, okay? So those are the only possibilities for zeros, or for rational zeros. And usually, or a lot of times I'll give you, you understand that? Okay? So I'm going to do synthetic division on this. I'm going to try 1 and see if that works. What do I put here? 1, then what? Very good. 0. Not 1, because there's no x squared term. You have to put a 0. 1 and 1, right? And then you bring down this 1. 1 times 1 is 1. Doesn't look like it's going to work, does it? You get 3. So this means that 1 is not a root. So what am I going to try instead? Negative 1. Now I'm going to try negative 1. Bring this straight down. That would turn that into a negative, right? That would turn that into a negative. This times negative 1 makes positive 1. Did I mess up? Negative 1. 0 plus negative 1 times negative 1 makes positive 1. 1 plus 1 makes 2. Negative 1. Negative 1 times this makes negative 2. And 1 plus negative 2 would make negative 1, right? So that doesn't work either, does it? Okay? Which means this has no rational roots, okay? So you can't factor it anymore, I don't think, okay? Let me make sure I'm correct on that. Okay? Let me look at my notes. Yeah, so this one, what I just showed is this one has no rational zeros, okay? No, not, no rational zeros. No rational roots, zeros, okay? Intercepts, say. Don't worry, we'll do one that works. What time do we get out? Oh, we got lots of time. Yeah.
No, we're out in 5 minutes.
Can I move on?
We got 5.
I see that. Okay. I did that one already. Why did the Bulls restaurant go out of business?
Why?
Because
Okay. There you go. I have to put that on my. I had to write on there so that. I'm trying to keep you awake.
what was that plus?
I made that one up. No, not quite. Okay. So so we're gonna Descartes' rule of signs. This looks very horrible. So, but it's not that bad. We're gonna do one where we actually find the rational roots. So just hold on for a few seconds, okay? So the number of positive zeros of f is either equal to the number of variations in sine of f of x, or less than that number by an even integer. What? The number of negative real zeros of f is either equal to the number of variations in sine of f of negative x, or less than that number by an even integer.
-2, -4, -6.
A factor which has a higher multiplicity than 1 counts as that many. Okay? This is what this means. Okay? Let me explain, because it's like really math talk, you know, and it's hard to understand what they mean. So notice that this changes signs from positive to negative to positive. You understand that? Okay? The sign, and you don't need to put a zero term in there. All you need to know is that this changes from positive to negative to positive. Okay? So that's 2 changes in sign. You understand that? 2 changes in sign? Right? Positive, from positive to negative, from negative to positive. So that's 2 changes. So then you look at rule 1. The number of positive real zeros of f is either equal to the number in variations of sign or less than that number by an even integer, which means that on the right side of the y-axis, I either have 2 roots or I have less than that by an even number. Or how many roots? 0. Okay, that's what that means. Okay? That's what that, so it means that if this changes sign twice, I either have 2 roots or I have 0 roots. If it changes sign 4 times, positive roots on the right side of my equation. And these are just methods that they used to use for finding zeros when we didn't have, it's a way to squish them down and zoom in, more or less, before we had graphing calculators and stuff. Okay? And what this says, the next rule says, so I either have 2 or 0 positive, okay? 2 or 0 positive zeros. Positive, okay? Then what I do, the second part, this is where people mess up. And all I'm going to ask you on a test is, I'm not going to ask you to find them. I'm going to say, how many possible real zeros do I have? Positive real zeros, how many possible real negative zeros? So the next part involves taking negative x and plugging it in everywhere I see an x. So I'm going to take negative x, plug it in there, okay? I'm going to take, and you have to be really careful with your order of operations, negative x, plug it in there, and the 2 stays the same. Don't worry about this yet. We're just looking at this side of the equation, okay? So when I square cube negative x cubed, what do I get out? Negative x cubed, okay? When I negative 3 times negative x makes 3x, and 2 just stays 2. How many changes in sign do I have here? 1, okay? So there's 1 sign change, right? 1 sign change, which means that on the left side of the y-axis, I can have at most 1 0. You understand that? Okay? So look, it changes sign from negative to positive. It stays positive, right? So the sign doesn't change. So at most, I can have 1 on the left side. So if I look at the factored form of this, which is this, I have a 1 and a 1. So, and what this says, a factor which is a higher multiplicity than 1, like this can be written as x minus 1 squared, okay, counts as 2 roots. So over here where I said I had 2 or 0 positive roots, I actually have 1 double root, right? And then how many negative roots do I have? Looking at the factored form of this, where does it go through the x-axis? At negative 2, right? So it bounces here at 1, and then it goes through there at negative 2, okay? And so it's just kind of a way to figure out, to narrow down what my roots are, where they are, how many I can have, how many on the right side, how many on the left side. There's another rule on putting restrictions on the highest, the highest possible root and the lowest possible root, but we kind of skipped that. So, you get that? Okay. But there is going to be a test question that asks you how many possible positive rational roots, how many positive negative. Could I have 0? Could I have 0 roots on the left side? No, because it's not less than 1. It's not. It would have to be 2 less than 1, which would give me negative 1, right? And you can't have negative 1 roots. You understand that? So you have to have at least 1. You have to have at least 1 negative root in this case. I think. Yeah. All right. Use Descartes to determine the number of positive roots. You want to try that one? Can I help you? You try. Tell me what the answer is. A, B, C, or D. We're going to pause. Wait. How do I, wait.
Wait, I thought it was always 2.
No, go back.
Yes.
I just want to pause my, oh, there's the pause. Where's the pause? Where is it? Oh, there it is. Because I want you to, sorry, I'm going to get there. Okay, let's go back to where we were. Where were we? There we were. Am I recording again? Okay. 101. Where'd it go? This. Okay, so the answer was B. Okay, and the way I get that answer is by, so this thing changes sign. From here to here is 1 sign change, 2 sign change, 3 sign changes, right? So on the positive side, I have either 3, right? 3 rational roots, or how many? 1, okay? Now, to find the negative possible, this is where you got to be kind of clever, okay? This is 2 times negative x raised to the 3, right? Minus 4 times negative x raised to the 2, right? Plus 4 times negative x minus 2. If I multiply this all out, this becomes negative 2x cubed. This becomes, you have to square this first, which makes it positive, right? And then you multiply by negative, which makes it negative 4x squared. So you have to really pay attention to your order of operations. Minus 4x minus 2. How many sign changes? None, okay? So I could have no real roots over here. you say, how could that be? Well, this could be a cubic function, right? But it could be doing, it could kind of come from down here, and it could not cross on that side, right? It could go like, it could go 3 or 1. So it could do something like this, couldn't it? That would be 3. Okay, it could just go through there, or it could be over here and do something like this and not have any roots on this side. Yes, ma'am. No, it's how many times the function changes sign, right? So the function, what happened? Ah, use your error. So from this changes from positive to negative, right? Anna? Positive to negative, that's 1 sign change. Negative to positive, 2 sign change. It's because it says it's either equal to the number of sign changes or an even number less than the number of sign changes. So it's either 3 or 2 less than 3, which is 1. Okay? If it were like a 5th degree equation and maybe it changes sign 5 times, then I might have 5 zeros or 3 or 1. Right? It goes down by 2 each time. Okay? It depends on how many times the sign changes. If it were, if you had 4, then you would have either 4 zeros, 2 zeros, or 0
But
zeros.
if you still had 5, couldn't you take away 4? Because that's an even integer. Like 5 minus.
Yeah, 5 minus 4 would be 1, right? So, so if you had 5 sign changes, you could have either 5. No, you wouldn't have 5, 3, or 1,
Right.
If you had 4 sign changes, then you have either 4, 2,
I just
or
don't
0.
understand why you have to subtract it by 2, because 4 is an even integer too. I don't know.
Because it has to do with how they finish and how they end. Because an odd function goes like that, right? An even function, one that has an even degree goes like that. Okay? Okay, so last problem, find all the real zeros of this. Let's just try to do it. And I will usually give you something like this. Hint, 1 real 0 is 2. So before I do synthetic division on this, I would factor something out. What would you factor out from all of these? X, okay? X times, I tried to factor out a 2 too, but that didn't work with the 15. That didn't work so well with the 15. I tried that last night, don't worry, you're not. Okay, minus 15x squared minus 16x plus 12, right? And then you have to try to factor this, but I tell you this would be like a test. 1 0 is 2, okay? So I'm going to put the 2 out here in the box, and I'm going to use synthetic division on this part. 10 minus 15 minus 16, 12, right? And I'm going to bring this straight down. 10, 20, tell me if I mess up. 10, 20, 5, 2 times 5 is 10. Oh, it worked. Minus 6, right? 2 times minus 6 is negative 12. That means that x minus 2 is a factor, right? So far this thing factors to x times, because I factored out an x over here, right? X times x minus 2 times 10x squared plus 5x minus 6, okay? Now, this thing does not factor. I just want to go through one more thing, okay? This does not factor. How? Do you know how to factor using the quadratic formula?
Yeah.
You have to do it. So I'm just going to take you through that quadratic formula. X equals, so this, if you're using quadratic formula, negative b plus or minus the square root of b squared minus 4ac, that whole thing over 2a. Okay? So if it's got a square root in it, it's not a rational root anymore. Okay? And so x, so I'm going to use a quadratic formula on this part right here. So negative b is negative 5, right? Plus or minus the square root of b squared, 25, minus negative 4 times 10, 6 times 10. What would that be? 240? All right? 6 times 10 is 6, negative 240. Okay? Over 20. You guys with me? There? Okay? Which makes negative 5 plus or minus the square root of 269? 265. Sorry, 265 divided by 20. Okay? Is there a 20? There's no factor 25 in there, so I can't reduce that anymore. Okay? I don't think. There's no. Could I pull out a 5? No, because I'd have to be able to pull out a 25, right? Not a 5. Is that what you're going to say?
No, can you break the like -5 and 20?
You can't because you'd have to pull out a common factor out of there as well, which I can't do. Right? I can't just cross this out with that because I have to cross out. It's the whole thing added together. Right? If I have 3 plus 5 over 6, I can't just do that and turn it into a 2 because I'm ignoring the 5. See?
Right. Couldn't you do like -1/4 or whatever that is? Plus
Oh, you can do that. Yeah, but I'd like to do it. Okay? So then, I'm not quite done. Okay? So then, what this means is that the total factorization of this thing is x times x minus 2 times x minus, in parentheses, negative 5 plus square root of 265 over 2, right? And times x minus negative 5 minus square root of 265 over 2. Okay? Over 20, sorry. Over 20. Okay? So that would be your 2. I'm missing a parentheses over it. Right? Okay? So that would be the total factorization with this ugly thing over there. Okay? It's kind of ugly, but that's how you do it. Okay? That's the end, I think. Is it? I think we got extra time in this group. Look! Not that much! Yay! You can root for the donkeys this weekend. Okay. I'll get that back up.